Okay, so welcome to the webinar. I'll just quickly open the chat. So I'm planning to do a brief-ish session today, so perhaps an hour, maybe just over an hour today, and quite an interesting topic: symmetries in geometry. And you've touched this topic in GCSE, of course. We'll try to make a slightly more formal approach to the topic. So yeah, welcome. So we're talking about isometries, and isometry is a transformation where the distance between any 2 points stays the same. Okay, so for example, if you have a triangle, the triangle is transformed into a triangle. In fact, it is transformed into a say equal triangle, not equal, but what's the word? Congruent. Congruent. So a triangle is transformed into a congruent triangle. A square is transformed into a square, etc. Not all transformations work that way. In your further maths A-level course, you will be doing transformations in the complex plane, where a straight line can be transformed into a circle, and vice versa. A circle can be transformed into a straight line, etc. So lots of interesting things that can be done in the complex plane, but that's a whole other story. So today we're talking about simple stuff: translation, rotation, reflection, and point reflection. So point reflection is the same as an enlargement with a scale factor -1, by the way. Anyways, translation. So translation, when all points move by the same vector. And the vector is v. So for example, a translation by vector 2i plus 3j. So there's a translation 2 to the right and 3 up. 2 right and 3 up translation. Rotation about a point, angle theta. So for example, rotation about point A at 40 degrees. So that's an counterclockwise rotation, 40 degrees about point A. So I hope this is self-explanatory. Counterclockwise because positive angle is counterclockwise, negative angles means clockwise. This is just this is just an agreement between mathematicians around the world that negative angles are clockwise, positive angles counterclockwise. Reflection in a line, so it's a reflection. So for example, r to x plus 1 is, or y equals 2x plus 1 is a reflection in the line y equals 2x plus 1. And point reflection, so S A, for example, it's a reflection about point A. It's the same as, aka, rotation 180 degrees about A, and it's the same as enlargement scale factor -1 about A. So if you have a shape, so for example like this, and you have a point, so all the points are reflected like this. So that would be a point reflection. So this is point A. This is the shape, and this is the image. I hope that makes sense. Any questions so far? I hope you all understand what a reflection is, what a rotation is, and a translation. So I don't really need to explain that. Okay, good. Now, problem 2. What does this transformation do? So when I was studying transformations, I struggled to understand the notation. Like, what does that mean? Like, what is x dash equals x plus 3 and y dash equals y plus 3? Well, a transformation takes something and transforms it. We say it creates an image. It takes the original shape and makes an image. So if xy is a point, then x dash y dash is the image of this point. And this is just the rule. This is just the rule. So to understand what the transformation does, the easiest way is to take a shape and take a shape, let's say a square. X, Y, and for simplicity, let's say that this is, well, A, which is 0, 0, B, which is, well, it's plus 3 and plus 4, isn't it? Let's see if we can fit it. Yeah. 2, 3, 4. 1, 2. Yeah, it's fine. This is 1, 0. C, which is 1, 1. And D, which is 0, 1. So this is the original square. We want to know what is the image of that square. So find image of square ABCD using the rule. So we have this rule. So we have x dash is x plus 3 and y dash is y plus 4. It's quite self-explanatory. So basically add 3 to every x and add 4 to every y. So A dash is the image of A. A dash is equal to 0 plus 3 and 0 plus 4. So that's going to be 3, 4. 1, 2, 3. 1, 2, 3, 4. So this is A dash, which has coordinates 3, 4. B dash, that's the image of B and has coordinates 4, 4. C has coordinates 5, 5. And D has coordinates 4. Oh, sorry, 3. So that's 4, 5. And this is 3, 5. And that's the image of this. And you can clearly see that this is a translation by vector 3, 4. Or in our notation T, 3I plus 4J. That's it. What does this transformation do? Well, you don't have to use a square, or you can use a rectangle. So A, 0, 0, B, 2, 0. I'm just using 1 and 2. C is 2, 1. And D is 0, 1. So let's take this square and see what happens to that square if we do this transformation. So A, which is 0, 0, becomes A dash. Now, x, the new x is the old y, so that's 0, and the new y is the old x, so 0. Okay, so A dash doesn't change. B, which is 2, 0, becomes, what is B dash? Oh, sorry. Okay. Look, x and y are the old coordinates, and the x dash, y dash is the new. So the new x is the old y. So the new x coordinate is the y coordinate of the original point. So it's 0. And the new y, y dash, is x, which is 2. Does that make sense? What is C dash? What does C become? 1, 2, yeah. 1, 2. So basically x and y switch around, and D, which is 0, 1, becomes D dash, which is 1, 0. All right, so let's have a look at this transformation. So A dash, that's here. B dash, 0, 2, that's here. C dash is 1, 2. And D dash is this. What is this transformation? Can somebody recognize it? Yes, it's a reflection in the line y equals x. Exactly. Y equals x. The transformation is a reflection in y equals x line. Okay. Okay. Let's do the same. Let's do the same. The same square, and do this transformation. X and Y. So A 0, 0, B 2, 0, C 2, 1, and D 0, 1. So A dash, so A goes to A dash. So what's A dash? If A 0, 0, A dash is, well, easy, 0, 0. B becomes B dash. So what's B dash? B dash is 0, 2. Yes. C dash, minus 1, 2. Okay. Are others getting it? Okay. And D dash becomes minus 1, 0. So let's draw the new positions. So A dash is here. D dash is 0, 2. C dash is minus 1, 2. And D dash is 0, minus 1, 0. So it's this shape. What is this transformation? Rotation 90 degrees anticlockwise. Yes. Rotation 90 degrees counterclockwise. Or simply, and center 0, 0. So that would be a rotation in point 0, 0, 90 degrees. 90 degrees implies anticlockwise. Okay. Problem 3. Perform this transformation on a square 4x4. It doesn't have to be a square, 4x4 square, but let's just do it on a 4x4 square. Oh, shouldn't have done that. Okay, so it looks scary, but don't worry. So let's take a square and x, y. too short. Mm, okay. Can we? Let's do this. So A, 0, 0, B, 4, 0, C is 4, 4, and D is 0, 4. And then I just need to connect the dots. So good. Now A, which is 0, 0, becomes A dash, which is, well, 0 times square root of 3 minus 0, so that's 0. 0, 0, well, that's 0. Easy. B. B is 4, 0. So so B dash becomes x times, so that's 4 multiplied by square root of 3 over 2 minus 0, comma, and then 4 times a half plus 0. So B dash is 2 root 3, comma 2. C, which is 4, 4, becomes C dash, which is 4 times the root 3 over 2 minus 4 times a half, comma, and the y is 4 times a half plus 4 times square root of 3 over 2. So that's C dash, which is 2 root 3 minus 2, comma, 2 root 3 plus 2. And D, which is 0, 4, becomes D dash, which is 0 minus 4 times a half, so minus 2, comma, 0 plus 2 root 3. So that's D dash is minus 2, comma, 2 root 3. Okay, so the new points are 0, 0. That's A dash, which is 0, 0. B dash, so it's 2 root 3. So 2 root 3 is 2 times 1.7, so it's about 3.4. 3.4, so that's here. And 2, so that's B dash, which is 2 root 3, comma 2. C dash is 2 root 3 minus 2. So that's 2 times 1.7, so 3.4. 3.4 minus 2, that's 1.4. So about 1.4. So somewhere here. And or 3.4 plus 2, that's 5.4. So that would be this. Does that make sense? Not really. No, it has to. Okay, C dash. And D dash is minus 2, and 2 root 3. So 2 root 3 is 3.4. Aha, interesting. So the new shape is like this. So what's the transformation? Can someone work it out? Well, I mean, at least what type of transformation is it? It is. It is a rotation 30 degrees about the origin, indeed. You can work out that this is 30 degrees. How would you work that out? Well, this is 2. This is 2. And this is 2 square root of 3. And this angle, phi. So tan phi is 2 over 2 root 3. So it's 1 over root 3. And we know that phi is arctan, 1 over root 3, and that is 30 degrees. So it's a rotation 30 degrees. So rotation 30 degrees. Well, I don't need to say counterclockwise because 30 degrees already implies counterclockwise. So about the 0.00. Now, interestingly, the way I've written it, you can actually rewrite this in this form. Equals. This is cos 30. So x multiplied by cos 30 degrees minus y multiplied by sine 30 degrees equals x multiplied by sine 30 degrees plus y multiplied by cos 30 degrees. In general, a rotation by phi degrees looks like this. X dash is x multiplied by cos phi minus y multiplied by sine phi. Y dash is x sine phi plus y cos phi. This is the formula. Now in the assignment, you're asked to perform 2 rotations. So imagine you do one rotation and then you do another rotation. So let's do an example. Do rotation by 20 degrees, then by 40 degrees. So you would do x dash. So you do x, y, transforming into x dash, y dash. So that's the first transformation. And then another transformation is x double dash, y double dash. So the first transformation is by 20 degrees. So x dash is equal to x multiplied by cos 20 minus y sine 20. Y dash is x sine 20 plus y cos 20. Right. Now x double dash is a transformation of this point into by 40 degrees. So that's going to be x dash cos 40 minus y dash sine 40. Y double dash is x dash sine 40 plus y dash cos 40. And now you substitute the x dash. That's a bit of an arduous task, but it's doable. It's going to be x cos 20 minus y sine 20 multiplied by cos 40 minus y dash, so x sine 20 plus y cos 20 multiplied by sine 40. And it's a plus. And then you can simplify that. If you open the brackets, you can simplify x double dash is x cos 20. So it's going to be x cos 20 cos 40 minus sine 20 sine 40 plus, or you can say minus y sine 20 cos 40 plus minus plus cos 20 sine 40. Y double dash is x open bracket cos 20. I'm just opening the brackets and rearranging. Cos 20 sine 40 plus sine 20 cos 40 plus y minus sine 20 sine 40 plus cos 20 cos 40. But then, if you notice, if you're really observant, what is this? Can you simplify this part? Cos 20 cos 40, sine 20 sine 40. Does anyone recognize it? Cos 20 plus 40, that's simply cos 60. Yes, can you see it now? That this is cos 60. And this is cos 60. And then sine A plus B in a similar fashion. That is sine A cos B plus sine B cos A. So that's sine 60. And this is sine 60. So a rotation by 20 degrees followed by a rotation by 40 degrees, it's the same as a rotation by 60 degrees. Who would have thought? So let's do it in green. So x double dash is x cos 60 minus y sine 60. Y double dash is x sine 60 plus y cos 60. It's the same as rotation by 60 degrees. Cool. So that's a sequence of transformations. Right, problem 4. This is a reflection. So this is a problem where you are standing at A, holding an empty bucket. And you see a burning shed at B. So you are standing at A with an empty bucket. You are standing at A with an empty bucket. You see a burning shed at B. Okay, no one is in danger. Nevertheless, you feel that it would be beneficial if you grabbed some water from the lake and put out the fire. Okay. What is the shortest path, basically? How would you run to the lake and then with a full bucket? Well, we have to assume that you run with an empty bucket just as fast as you would run with a full bucket. Otherwise, it's a whole other problem. Would you sort of midway along the river between the person and the house? Let's look at the problem from the top and the aerial view. So this is the lake. This is the lake. This is the shed. And this is you. Midway, so you think this point? Let's take it to the, is it this point basically? To understand whether this is a valid answer, let's consider an extreme case. Extreme case. Imagine that you are standing really close to the river. Really close to the river. Would you still run to this point? Would you still run to the midpoint? So yeah, somebody suggested that the midpoint, which seems reasonable. Midpoint. So let's say this is the midpoint, M. If you're standing at A1, like let's say it's an extreme case, you're really close to the lake, would you still run to the point A to get a bucket of water, or would you run to the lake, grab a bucket, and then run straight to the shed? Because clearly that's going to be faster. You go to the lake and then to the shed. No? Do you understand my issue with this solution? It's probably not the midpoint. Yes? No? Someone? You can solve it by differentiation, yes. Very good. I mean, by all means, please do. But you don't need to. Don't have to do it by differentiation. As a matter of fact, so you solve it by reflection. So you reflect point A in the shoreline. So you reflect point A. Reflect solution. Reflect A in line L. So this is line L. And okay, this is A dash. That's the reflection of A. And then just draw a straight line. Draw a straight line from A to the shed. And that's the point where you need to grab the water. And this, let's call it point G for grab. This is the B. And of course, if you were to draw a normal line here, because this angle is equal to this angle, of course, that means that this angle is equal to this angle. So theta 1 equals to theta 2. What does this remind you of? Draw a lower reflection, A dash B. Dash B, point G. G. And then G is the point. So shortest if theta 1 equals to theta 2. That is the law of reflection, yes. Light, as we already know from physics, light takes the shortest path. So light reflects, and so should you. You should reflect off the river, and that would be your shortest path. And you can show that if you choose any other point, that would not be the case. The path would not be shortest. Okay, finally, I want to talk about problem 2. So redraw triangle ABC. So not triangle ABC, let's do rectangle ABCD. And let's take a simple triangle ABCD. ABCD. Now, you do need to do these transformations. Now, you do the transformations from right to left. So first you reflect it in point, it's a point reflection on A. So point reflection on A, so B goes here, D goes here, C goes here. So that's A dash, D dash, B dash, and C dash. That's the first transformation. Sorry, I'm very tired. Okay. So D dash, C dash. Okay, now take a different color, and I'm going to draw the second transformation. It's reflection in the line AB. Oh, it's this point. So this is A double dash, B double dash, C double dash, D double dash. In a rotation 90 degrees about point A. Rotation 90 degrees about point A, so it becomes this. Okay. And so this is A double triple dash. This is D triple dash, C triple dash, and B. Is it B triple dash? Yeah. So that's the final image. And then you do the second one. The second one is a rotation followed by a reflection, so followed by a point reflection. Okay. Let me just quickly do this. So let's take the rectangle ABCD. So first you do a first we do a rotation 90 degrees. So that becomes this. Then you do a reflection in the line AB. So that's green. Reflection in the line AB, which is the line AB. AB is this, so it becomes this. And then finally reflection in the point A. Does look like it's the same. What do we take as line AB though? Do we take line AB as the original? Well, I think we have to take the line AB as the original point. So we have to reflect it in the line AB, this line AB. This is the line, this is the initial line AB, so it's like this. And then we reflect it in a point SA, which is this. So we got a different result. By applying the same three transformations in a different order, we get different results. So yes, please please do that with the triangle though in the assignment. Like, I have to go, and I hope that was useful. Sorry that I can't stay longer, and see you all next week, I believe. So you're welcome. Webinars, just double check. So yeah, spherical lenses and mirrors, that's the next assignment. Oh. Okay, yeah, all right, see you then.